Good morning, everyone. So it's my turn to tell you some lies and tell you some stories. Elena has been asking us to introduce ourselves a little bit longer. I don't like talking about myself, so I guess I already mentioned yesterday I have a education in computer science, undergrad and the master's. The Brazilian master is quite long, it's not the Bologna master. And then I had a PhD in computer engineering in Germany. I've been doing operating system and basic software related stuff, very close to hardware, whenever needed hardware as well, my whole life. But the application area changed a lot. Whenever the industry moves and say, well, we have demands for specific software development and hardware development in this area, we go there. So the core is the same, but the application area has been changing every 3, 4, 5 years whenever we get a good bulk of demand from the industry. Perhaps the most important one was the digital television in Brazil. Brazil opted for having its own system. We designed the system, and the final day they opted for taking the Japanese version. But it was not the Japanese version used in Japan. We got at least to be the first one to introduce H.264, to introduce full HD on a public and open broadcast television. So we use the modulation and transmission techniques from Japan, but we improved that a lot. And at that time, my lab was responsible for taking several chipsets from different companies, produce some basic boards for the Brazilian industry with the same software. Well, you might say all of them run Linux, so it was very easy. They run a kind of Linux made in-home by each silicon provider, so that was not actually Linux. And GStreamer was not there at that time. So we built the boards, and then we produced a layer of software that enabled the Brazilian industry to produce higher level software, portable across a variety of different chip providers. Sensing and Internet of Things and wireless is even older than that, but the Brazilian industry took very long, so it was something we've been doing on our own expenses because it was very late that the Brazilian industry realized that there is a sensing market and there is something to be developed there. In 2004, we used these self-made boards to monitor underground transformers in downtown, the largest one we have in town. So the electric distribution company use our technology to monitor demand and to cut and to prevent overheating and things like that. Then we have demands from agriculture. We produce very small sensor. And the point is that the same components, the same software components from the digital television scaled down to 8-bit microcontrollers. So this is the core research in the group. Produce things that can be automatically adjusted and packaged in completely new environment. So it's a 20-year-long project of building software and hardware components highly adaptable to whatever comes. So this has been used in precision agriculture in Brazil, coffee and cotton. Then we moved to produce boards for the universities, larger ones with USB programming, GDB, QEMU support, and things like that. And the third generation, which is the one used in the building, is the compromise. It's much larger than the first generation 10 years ago, but it retains all the easiness of programming and using like an Arduino board. You can very easily simulate on the PC, use GDB, use QEMU, and then download your software here based on our operating system. So this is now something used both at the academia for teaching and by the industry. We have a partner industry using that extensively at the moment. But let's focus on a subject for today. Microgrids in the Internet of Things. You all are very aware of what a microgrid is. I could spend hours talking about the controls. That is what we've been doing in this building and for the city in the last 15 years. But I guess this is mostly a solved issue in terms of science. And I mean, you all know that there is dozens of different communication technologies, different modes, different controllers, different SCADA systems. It's more about managing and installing properly all these monitoring and controlling technology than developing it. So I'll focus more on the Internet of Things because that's where the scientific challenging questions are still, it's not that they are still there, they are mounting, they are growing every day. Oh, sorry. So first to get a glimpse of on the problematic around IoT, let's first get things right. Everything is getting smart, everything is getting connected, everything is now low energy, green, and the dream of everybody is to be able to control and check that on the internet and have a complete human interaction, just like we do person to person, do that with your machines. Governments dream of smart cities. We had very good news from India yesterday. We have announcements in Brazil for something similar, but so far it's more about blah, blah, blah than real implementation. We have demonstrated things all around the country. This group itself ran a network with 18 other universities demonstrating alarms for floods and air pollution control and traffic control. But those are all demos, small scale, experimental installations. The big money to make our cities really smart haven't come yet, but in my particular opinion, I like this way at least for a couple of months, and I'll tell you why. Once all this get integrated, well, it's a powerful tool for decision takers. They now have real-time information about everything, but there's a lot of security issues to think about. And in parallel, we are doing the smart grid. This is something that hasn't been that extensively discussed by the society in Brazil, but I guess after Fukushima, it's not hard to convince someone that it's better to invest in making the old grid smart instead of building more and more and more power plants, especially if you are in a country that builds nuclear power plants. So this came more or less naturally in Brazil. Things are being updated. I would say to high tension, everything is automated. To mid tension, virtually most everything is automated. The last mile is the challenge, but someone has to see value on that before going. It's no longer a technological problem. What is interesting here is that the concept needed to interconnect these all, to interact, to integrate all these devices is very similar to many other things that is happening around. I lived in Germany. I know how Germans like to lay new cables and to have their private networks to ensure that trains never collide or things like that. But actually, one day this has to stop. You cannot have a new wireless network to control energy, another one for water, another one for trains, just to be sure that no one invades your network. One day, we'll have to put this all in a close, especially when you get close to the last mile. I mean, as you go down, you cannot afford having your own technology. So the final smartness of the smart grid is your house. We have to find a way to control the loads, to interact with your house, with your car, with preserving your privacy, and surely not laying down a new network technology, new wireless communication systems. As it comes inside your house, we also have very interesting demos in our group by the digital television time. So we had a Linux box with lots of spare processing power and memory. We opted 5-6 years ago to use the set-top box of your television as the gateway for a smart house. And then we demonstrated several things like adjusting lights according to the light that comes from outside, adjusting air conditioning according to the temperature, all based on the Linux on your digital TV. And coming back to the big plots to have the smart grids implemented in Brazil, we initially saw many energy companies looking for their own IT technologies for security reasons, re-implementing everything. And at that time, many of us said, well, it makes sense. Isolation is the best security one can have. But suddenly, it was so expensive, and the amount of data produced by these machines got so large that having everything implemented from scratch on a secondary, on a separate level, was no longer possible. So as an IT guy, we very quickly tried to bridge both communities. I mean, electric companies has the check. They are renewing the grid, and their projects are very large. They need IT infrastructures. And we have something called the cloud. So we quickly try to bridge both communities and say, we have already an infrastructure, we just have to make that safe, secure, and trustful. So coming to the Internet of Things, what all this has to do. So everything that is not a human being on a keyboard or on a touch screen is the Internet of Things. Whatever you connect and communicate, you can interact with, and it's not a computer, well, that's the Internet of Things. For many researchers in the last 15 years, in particular for some very large companies in the recent 5 years, there's no reason at all for the Internet of Things to be different from the Internet of People. So it's Internet, let it be Internet. But there are many things that have not been properly taken at the original design of the Internet. We are now talking about things that must care about energy. Things that are event-driven. They are cyber-physical systems. They have to react with the environment. They have a deep notion of time and space. It matters whether you do it now or whether you do it in a couple of seconds. It matters if it's here or if it's in Japan. So, of course, you can put new layers of patching over on top of the old Internet and try to get all those services. But come on, if you put more and more and more and more layers, you're making room for more and more bugs and for more and more invasions. So some companies, in particular, ABB in 2015 broadcasted this message along with Cisco saying the Internet is there, use it as it is. But other big companies like IBM are saying, no, we have to design new protocols. It's not the way of doing it, just using the Internet as it is, because it won't work. And what about big data? All these new buzzwords, there is a multi-billion market on renewal of telecom technology, switching, storage, because of big data. Hold your data, that is the most precious thing you have. Well, I'll talk a lot about this later. I'm not sure that this is right, this is wrong. The fact is that it is no longer a question. Until 2 years ago, I was pretending we had an influence on that, discussing it was too early, it was not safe, we got in trouble with people dying because it's no longer a question. It's happening, and it's happening massively. The companies are changing their infrastructure to store the data and trying to get intelligence out of the data they store. And of course, the electrical sector is not an exception. Everybody is now very precious about the data they produce and collect. The open issue is whether we can really drive intelligence out of that. If we do, then I suggest you to watch this movie. I guess this is what convinced me to put a PhD effort into this area. Let me try to explain you a little bit better. When Google starts to collect data from your phone and send it to a farm of computers somewhere else to process that and give you back an answer, that looked to me the most stupid thing one could do. You had processor in your pocket, you have an operating system able to manage energy. There was, well, if you go back to Nokia Symbian, you have all you need to process that in your pocket. Why send it to the cloud, have it processed there, get it back? If the cloud is not available, you run out of service. You're spending lots of energy to transmit it. You're not using your local processor that was idle for the time. At that time, it actually didn't make sense. But after watching this movie, I'm now one of the enthusiasts about this. What made me change the mind? When I began studying computer science, there was this promise of the 5th generation computers from Japan. Artificial intelligence was there. It was just about having a large enough computer, and they knew how to make a machine behave like a human. Well, machines improved a lot. We have lots of machines, and computers are as silly as they used to be a long time ago. But the fact that we send all our data to these cloud operators enabled them to use a very different technology for artificial intelligence. Instead of trying to program or try to mimic a brain, they simply start to look at patterns, at massive collections of data, And whenever you ask something similar, say, well, I saw a pattern of humans reacting like this at this case, so I give you back that. I don't know if it's right to call that artificial intelligence. I don't know if it's right to call that machine learning. But the fact is that we now have a perception that machines are intelligent. You ask something to your cell phone, and you get a very nice answer most of the time. So the Batman computer from the movies, it exists. It's in your pocket. How? By using brute force to interconnect, to analyze huge pieces of data. So the issue here is, if the authors of this movie realized that a machine can mimic a human just by sending back answers that it learned by spying in our own cell phones, are we able to control large, complex electrical systems just by spying or checking how humans are operating it for a couple of times? I don't have the answer, but this is the idea here. Collecting the data, but collecting the data in an organized fashion to enable quick and easy reasoning, researching, machine learning on that data. And perhaps, because, I mean, we discussed that on John's talk yesterday. It's very nice to control your air conditioning, your bulbs with your mobile 1 day, 2 days, perhaps a week. But who wants to control that manually forever? And say, well, let's use the traditional supervisory systems from large electrical companies to control our home. Well, but we bring new furniture every day, and most of these things are now smart things. So who's going to configure? Who's going to connect? Who's going to program your house all the time whenever you have a bulb change it from one place to another? It definitely won't be manual. It has to be automated. And it cannot be programmed. I mean, we now have to give an ID to each bulb to control it. Oh, come on. It doesn't make sense. It doesn't scale. It's boring. So are we able to learn how to manage and control a complex system simply by lurking into other people doing it? That's the point here. Or are we coming to an end as we do this? Well, this is the ethical question in all this research. It might be that on the fostering of this easiness of life and everything automated, we get in trouble. Some people even say trouble is already there. It's just that we didn't realize yet. And in my opinion, it's really there. It's a matter of days or weeks until an automated car kills someone. Oh, it didn't happen so far, it won't happen. Well, how many automated cars are driving around? How many are in uncontrolled environment? How many of them have been strolling through São Paulo or Mexico City or any large Indian city? So it's a matter of time. And if it not happens due to this fully automated car, then, well, there are other risks on automating things, especially if you know how to do it. Okay, this was about our perception of the Internet of Things. So it's not only the building, it's not only the sensor, it's everything. Everything that is not a human is under the same framework. We're going to face the same challenging questions for all of this. And as I mentioned to you, it's happening. This is just quick figures updated yesterday. I don't know if they just throw a coin to find out these numbers or whether there are really tough studies behind them. But the fact is that it's happening. It's no longer an open issue. It's being implemented, and there's a lot of resources on this. So, coming back to the scientific point of view, I hope I have motivated you that we have to pay attention on this because it's going to be huge. The issue now is which both set of companies are right, those that say use the Internet as it is, or should we perhaps redesign everything because it would be too risky to use the regional Internet. So our opinion is that we have definitely to rethink it over. We cannot simply use the old Internet, and I'll show you very technically now why. Well, before, I'm not the only one. Just open the newspaper and you're going to see breaking into systems on the traditional Internet happening every day. Every day. So let me try to make the point on why we have to think all this communication and all this monitoring infrastructure from scratch. Consider we have a very simple scenario in which we have the big brain trying to smartly control a city, and we have a house that wants to report fire. It would send a message, big brain, I detected fire. And we expect the brain to send rescue to that house. How would that happen if we use today's technology? Well, there are several sets of protocols, but let's begin with the oldest one, and I'll demonstrate to you that it isn't much advanced on the new ones. Just by checking the size, this is the most traditional historical perspective of services over the internet. Look at how many layers of software and hardware, how many components I have up to the point in which I can say fire. So, these are megabytes of code. This means lots of places for bugs, and as Herbert Boss from Amsterdam has been demonstrated, there is now artificial intelligence that can learn from your code, from the binary code, by stimulating it and finding breaches into your code. So they're very automated now. Hackers are very automated to find places to invade your system. If we use this huge historical protocol, putting a new layer on top of the older one just because, well, it was not designed for this, put another layer. Well, that layer was also not designed for this, put another layer. You end up with a huge stack that is very susceptible to fail and to invasions. Let's go further. How many bytes I have to transmit to tell something like that? This is the simplest example here. Just control information, and then I'm going to have here at the tail, very small, my 1 bit of information saying there's fire in my house. I spent 473 bytes to send 1 bit of information. Well, it's not over. It's not a single message. I have to establish connections. I have to establish security connections. So there are 14 of these messages to send 1 bit of information. And at the end, that information you receive will leave you with questions that are hard to answer. Was that true? Or is that message just been a replay attack? Is this a fire that happened today? Or hours ago and the house is burned down? The last register I have for that IP address is valid. Do I know where this house is? So after all this exchange of information, all this risky room for trouble, I still don't have very important information to make decisions. Oh, okay. This was the oldest. Soap is out, try cope. Well, it's just the same, and at the end I still have no location, no time information, and no trustfulness at all. Oh, but at least we can reduce the size. Use that on UDP, or even better, use that on 6LoWPAN. Well, now the size of the stack is really much, much smaller. There's less room for invasion, less room for trouble. But again, if I'm using IP, even IPv6, I don't have this critical information in a reliable way to take decisions. So what about other? There's a myriad of protocols coming up. IBM is pushing MQTT. There's the Zigbee Alliance. The BACnet is there for 20 years. There's 7 in Asia. Well, name whatever you want. In our opinion, there will always be a gateway between the Internet of Things and the Internet of People. This idea of using the very same Internet of People and machines will drive us into a situation that we have no longer control. I wouldn't lay down in an hospital bed with those equipments being controlled with a Linux machine running TCP/IP. Now, the key point is that our computers get invaded and we lose data. They don't move. They don't take decisions. We're now talking about cars, planes, traffic control signals, buildings. It's dangerous now. It's not the same thing that to say, just reboot it, try it again. No, it has to be redesigned so it will not happen by design. It's not a matter of having a clever programmer to close all possible doors. No, we're talking about designing things in such a way that there's no room for those things to happen. So in the last 15 years, we've been doing several of these building blocks for what could be, we're not saying that this is the solution, but what could be one solution for the Internet of Things, for control systems, for the smart grid, and that includes the traditional networking things like median access control, routing, but we also have security, timing, energy management from the very basic design of the protocols, the operating system. Everything has been designed as a single thing. This is a cross-layer design. It's an all-together. You cannot simply say, I don't want to use security now. Oh, location is not interesting for me now. No, it has been designed in such a way that if you get a message like this, then you certainly know that you can trust it. So our single bit would be sent in a single message, and as this message is dispatched to the rescue team, it would be authenticated, it would be geolocated, so I'm completely sure where it happened, and it would be timed, and timed to very high precision. For control system, we've demonstrated sub-microsecond synchronization. So all these bulbs in this building are synchronized to below 1 microsecond. And then hopefully the dark side will get confused. Again, for a single group to say, well, a line of protocols and building blocks developed for 15 years is a solution. Of course it's not the solution. We have some small pieces of the solution. The message, the important message is, do not buy Wi-Fi controllers and install your building based on those. Do not write passwords on the board to control your refrigerators or things like that. This is funny for a week or so. It's not the solution. You're going to get in trouble by doing that, especially if you are an engineering planning something large for a big company. The university demonstrators are not reality. We also have to be very flexible on tackling technology. Of course, we prefer this technology instead of that other one. I love PLC, I hate ZigBee. No. There is no one-size-fits-everyone in this scenario. We have to adapt processing and storage and communication to whatever it takes. In some cases, body networks, in human body networks, they have to be very well designed for heating dissipation and things like that. So it's not about what you like the most. It's about building blocks that can be reused in any of these scenarios. Okay, both about energy and communication. Whenever we design a solution, it will run in all set of technology available at the time. How will then things interact? I mean, if you design everything from scratch, how are you going to end up with that on my cell phone? How are we going to program that from my computer? Well, there is a gateway. Of course, we will still have Linux, Windows, and the very traditional real-time tough systems on the higher human interface devices or on the computers. We're talking about the small things up to the gateway. Okay? And again, we did that since 2001, and many people laugh on us, but now IBM is fostering this idea. So it's no longer a couple of professors suggesting that you cannot use TCP/IP or 6LoWPAN or IPv6 for the Internet of Things. Now you have very big companies saying that. A little bit about what you saw. In 2009, we got a project approved to build our own chip. Approving in Brazil doesn't mean paying. So we don't have the chip. We have designed the chip, but it wasn't fabricated, it wasn't implemented. What we did then is to move to FPGAs, and we have a design of a mode that has even offload capabilities for small modes. We have a multi-core system with 2 Cortex A9, a NOC design in-home, and the sensors plugged here. So we could demonstrate the SoC, but it has never been turned into a chip. Brazil has sometimes these ideas, well, let's do the RFID for cattle because we are large producers and we don't want to buy. And in one of those dreams, they said, well, we're going to use a lot of smart tags for automation. Instead of waiting China to adapt to Brazilian rules, let's produce ourselves. This was the demand that generated this. But when they came to the bill, they said, well, it's that expensive to make a chip, so let's wait for China to produce and buy when it's affordable. And this is what happened. But we will never give up. A little bit about joint stories now, how this has been used and what we're doing to face big data challenge and security challenge. We began with the digital television. As I mentioned, we had all the stack of software, and we introduced this concept of smart things, so we could get on your TV controls to interact with the devices you have at your house. This was in 2008, 2007, quite long ago. We integrated some machines into the digital TV system and give them connection to the internet. We also have a very strong call in Brazil for people doing ecological stuff and nature preservation, monitoring stuff. They've been using the role and say, well, give us the license and we will produce. Usually the users are producing this equipment themselves. So we installed one here outside. You can check it later just to demonstrate. But there are really several ones for pollution control, for flood control in the States. We have several stations now operating under our system using solar energy. It's just a small panel here, a small battery, and this is the board we have here. And the mode all the intelligence is very small here inside. The first interaction with Ricardo's group was on equipping the competition boat, the solar boat they were working with. So we had access to the project, and then we imagined we could install sensors and help them to navigate more efficiently. This competition is about having a track done with the battery almost empty on the shortest time. So if you go too slow, you have energy at the end, and you lose. If you go too fast, you don't reach the final line. And we help them to equip and to monitor conditions for them to drive optimally. We would like to have this posed with the driver and the pilot and use a computer to do that, but that was against the rules. We have to have someone. So this is the boat built, and someone from Ricardo's team piloting it. We ranked first in Brazil. We went to Europe. The story there was a little bit different. They have massive investment from companies, but it was very nice to join all this team for this competition. Then came the building. You are in. It's no longer a project. It's here. And let me talk a little bit just for you to get a notion what is automated and what is integrated. The first thing is that we have a dream of having the whole building in a backup system. Everything will be we start at 9, yeah. Everything will be backed up, but then we have a very smart control because the backup is not strong enough to hold the whole building. So we have to deactivate load very efficiently, very precisely, not to overload the backup system. But the idea is to let, instead of segmenting the electrical design, is to have everything on backup and let the smartness of the building decide which loads should be preserved, which are critical at this moment on an individual points. For this, we have used these modes with load sensors and controlling technologies in all outlets in the rooms here in front, in all bulbs. So for every load, we have one of these. And this is actually now being commercially explored by a local company called ComSE. We are about to plug into the grid, and then we're going to have a very quick advance towards what you would perceive as intelligence. We would stop doing predictive, adaptive control and would do predictive control. Ricardo and my group have been investigating cloud coverage, weather, climate, correlation with temperature, with the day of year, with the district behavior for that time, for us to say something like this. Well, we are not producing that much energy now, but we'll let you use, we'll let you adjust your comfort level to something that is more expensive, because we know we will recover this. So this is the dream for this backup system, is to allow the system to go beyond the limit, because we have predictors that are able to ensure that we won't have a blackout. We are still waiting the final connection to demonstrate this, but this Arleones is here. He's been doing his PhD on this. So we come back to the brain. As you instrument the electrical system, we connect that to the brain. And what is actually the brain? So since we assume that there is a gateway, we have strong security, authentication, location, and timing from here to here, from here to here. But from here to the rest, well, that's the original internet. Cloud computing has been there for 20 years, doing an excellent job in storage and processing. So we just checked what most groups are doing to do machine learning and to use the data smartly. And we conclude that we should use a set of tools. We then split it in 2 big blocks. For electrical engineers, we deliver a SCADA system. It's what they know, it's what they like. I'll tell you a secret. Only you electrical engineers like it. IT people don't understand how it's going to work. It's really a trouble to explain anyone outside the electrical sector why would someone use something like this. But okay, it is there because it's what you're used to. From this side, we are storing all series, so we have sensors that produce information every second or so. We're storing everything in time series. Kairos DB organize everything in time series in such a way that this parallel computing system can quickly access huge series of data and look for relationship within. And Grafana is used for visualization. This is what you have here in front. So far, well, I have a slide on that. So far, we are still not 100% sure that, now it really stopped. That this will lead us to the dangerous situation into which everything is really smart and then we are out of luck, or whether this is about the most expensive buzzword ever. It might be that all this effort to install huge databases and to interconnect everything because the machines will learn how to manage your system won't come. And this is not my opinion alone. We've been going to all conferences in the area, and what we see ever and ever again is that a machine learned how to optimize the control of one small system, which physicists and engineers described 100 years ago. Okay, great, the machine learned that by itself, but we knew that already. So I get 0.1% improvement because now the machine got the final parameter fine-tuned. No, I'd like the machine to learn something we don't know yet. And this is missing. This is to be demonstrated. Sometimes people come up with very, very funny relationships. Lucas showed us things like the number of kids born to blonde girls when the popcorn, blah, blah, blah. So who cares? It looks like more or less random pattern matching. What we'd like to see someone demonstrating that the machine can learn something 100 years or 200 years of electrical engineer wasn't able to find. Some relationship, some control roles, some adjustments, some fine-tuning strategies. That is not straightforward to us. We did k-means, we did clustering, we did the basic machine learning on our data, and yes, it can find things. But when I tell Ricardo's group that we found that, it's in our class book for the first term. So the 2 points is that For us to reach the dream of self-controlled microgrids, we have first to care for security. If we go installing this ordinary Wi-Fi stuff around, it's going to put us in a bad situation. It will be hacked all the time. We're going to get trouble all the time. And doubling the network was a solution when it was cable. Now that it's wireless, well, it's just about parking the car in front and you reproduce everything and you disrupt a whole industry if it's not secured. So before we can claim that we can autonomously control the electrical world, we still need help from security people. There's a long mile to go in that direction. And all this movement of collecting data and try to control the system from the data, well, it still has to be demonstrated. We now believe in this after watching the movie. So it was a fictional and not a scientific source of inspiration that put us in this track because of our cell phones. Well, it worked for many things we consider now to be intelligent. It might be that we will find, it's just that we don't have the expertise, we're not collaborating with groups of machine learning that can know how to do that. But the fact is that we've been going to conference for 3 years looking for that. Who has found a relationship that was not in the books? And so far, we don't have much of that. Thank you. This was it. We can go to the question.
It wasn't a question.
I
did say that all I meant to say to your question as to whether anyone has found relationships, that every now and again you do fall over them, maybe sometimes by accident. But I think the bigger problem with big data, in my opinion, I absolutely align with your line of thought there, is that we don't know what we are looking for at all. Nobody is specifying the problem that we are trying to resolve. And in that circumstance, it is only by accident that we are always going to come across interesting relationships. So the lack of user intent and clear specification of what there is to be resolved, what there is to be done, I think prevents the machine learning specialists from doing a really fabulous job on big data.
But if we have to specify, don't you think that we'll have to understand the problem and get at least the physics on it?
Precisely. So we need to understand the problem, we need to understand what we are looking for, and then we need to create machine learning driven systems that can help us find that answer that is not immediately obvious otherwise.
Yeah, sure.
We work with users as well, and I think we've got a lot of commonality in the way we came across the Internet of Things and wireless sensing, in that we developed some transferable technologies and bits and pieces of software and hardware, and then apply those to a large range of applications areas. And time after time, 7 or 8 industries that we worked with, the hardest thing in each project was to draw from the end user what they want, what they are after. They all wanted wireless sensing, they all wanted to find out things from data, but when it came to what exactly do you want to know about your building, about your energy, about your user behavior, it was very hard to draw precise answers.
Yeah, but consider now next generation you go to the supermarket and you come back with an appliance, and that's smart. So you will be changing your configuration whenever you go to the supermarket. If you have to program or if you have to give some hints on how to behave with that, well, it won't be done. The house, the environment, the smart space has to learn automatically that something has been inserted, and I have to know what to do with this. What is the priority I give that? Is that something that is allowed to consume energy all the time, or should I shut it off whenever there's nobody here? If we have to tell the system that I introduce a new appliance and this appliance is human dependent, it won't work. It works nowadays. We have 2, 3, but well, one day we'll buy the butter and there will be a sensor saying, well, this should go into the fridge, and it will consume energy and things like this. So our dream was to interact with a group that could say, you don't have to specify the problem. We'll try to find on ourselves, and that would be true artificial intelligence in our opinion. But we are not those guys. We're just saying that this is our limitation. We are organizing the data in such a way that those folks can easily access easily upload their parallel programs to investigate our data and try to find this. But so far, it's an open question for me. And Elena just believed that we need to help them specify.
Absolutely. We've got data on homes, from homes, over 300 homes in the UK. Some of the deployments of wireless sensing that we've done are older than 2 years. It's masses and masses of data points, and we don't know what to do with them, because at the end of the day, the homeowners don't know what they want to find out from the environmental and energy data. They don't know what's meaningful to them. The commissioner of the projects, who put more than £1 million, a variety of sponsors, including the government, into us deploying the sensor systems and collecting the data, don't know what they want to do with the data. So I think it was all a self-congratulating exercise that we can produce cheap sensors, we can deploy them in homes, we can make them last forever, and now we are sitting on data banks that, by the way, are free to be used. And we are looking at maybe how many smokers there are from the CO2 patterns, how many times a week people are entertaining, again, from occupancy and CO2 patterns, what is the average temperature, so all sorts of really basic, uninteresting, and not at all useful things.
Thanks, Elena. This is exactly the situation we are in now. I guess
so we come to facilitate them using the problem structuring methods, so that they can identify their own problems, without support as it could be taken.
I guess one thing computer scientists very quickly learn with engineers is that there are methodologies for mostly everything, and if you specify your problem nicely, you most likely will end up with a set of differential equations that will solve your problem, model the reality in a good approximation. The point is, here is that for most users, they don't want to model or to tell anything. We now buy butter without saying anything about buying butter. So who will ever one day program the refrigerators to send an alarm whenever I forget the butter outside the refrigerator? Well, what if I like it outside or something like, it's no longer tangible to use traditional engineering techniques to that small level of details, both because of complexity, it's an explosion, the scale is huge, and second, because it will somehow disturb our daily lives. It has to be somehow driven from itself. Of course, there is a methodology to learn that from itself, but this is exactly the point we are mentioning. We are in a stage where it's tough to say, well, it will happen. We will do it automatically. It will learn. So far, it's easy to replicate what we could do with these methodologies by hand. The next step is still on the horizon. We believe on it, but I would be naive to say that it will happen in 5 years. I don't know if it will happen in 20 years.
Not working. Just Hi.
Okay. Yeah. Thank you for a very interesting talk. One thing that I guess my question to you about these sensors is whether they're able to get us closer towards linking energy use of appliances, of devices, and linking those to what people are doing. So like their actual behavior, their activities, their social practices. There's a big gap in knowledge between what people do in terms of their activities and the eventual appliance and the and energy use, and that's an important gap that needs to be bridged, or there'd be value to bridge that when we're looking into futures where we need to influence energy demand behavior. And I'm wondering, there's obviously lots of progress on making an Internet of Things, but how is this technology able to make that extra jump between linking that to what people are doing and why they're using energy? You know, answering the why question.
Yeah, but it's a question to a question to which I can only give you another question. I mean, one thing I can say about this is that, well, if you use traditional social networking and mobile phone spine or data capturing technology, you say it's for free, it gives me the right answer 99% of the time, so it's okay. But hospital, about the traffic lights, 99% is not enough. So these from the same, mostly correct is okay, critical things. And this is perhaps the reason why we'll never reach everything. So it will be consumables, appliances, but there are some companies saying we'll never have a machinery in a hospital connected to the internet. We'll never have defense systems connected to the internet or something like that. But of course, researchers are doing. I mean, many guys from social knowledge, best, and if I fail
Data
that level, then the SCADA system, the supervision, something to control. In 1,000 devices in 10 years, or control these like these like that, up to a level. Yes, after that, it has to detect that something has been brought into what it is. So in our protocol, for instance, we have an API in which the sensors, IP numbers or IDs are. It would be silly for us to say we know what to do with that. We know what to do with